much for coming along to this webinar hangout. So as we mentioned in most of the registration stuff, we want this to be a fairly open discussion, so we will be accepting questions from the audience. So feel free to send a message in via the chat box or via the questions in the GoToWebinar interface. Just to give a brief background here, so the Big Data Europe project has been running for the last 2 years. It finishes this month and has been aimed at building a foundational infrastructure to help reduce barriers to getting involved in big data across all of the major societal challenges in the Horizon 2020 scheme. So Open PHACTS has been the pilot project in Societal Challenge 1, which is about health, demographic change and well-being. And as part of that, we try to organize some webinars and hangouts to talk to people in the community about their big data needs and challenges. And so the aim of this webinar will be to talk about updating public databases in terms of challenges of automation for consumers and for creators of databases. So I'll hand over to Nick to introduce our panelists and to get the webinar started.
Thanks, Kira, and thank you all for joining us this afternoon or this morning. Could we move to the next slide, Kira? Just to let you know, we'll be recording this webinar and we'll make it available off our website later on this week, and as well as the slides or the questions that have been asked. Could we go to the next slide? We're very grateful for our two panelists this afternoon, and I'll spend a little bit of time introducing them as well. So Dr. Evan Bolton runs the chemistry program at the NCBI. Probably one of their more famous systems that they support and create has been the PubChem infrastructure, which is probably the largest collection of published compounds and other sample material, sample information connected to research literature across the globe. And Evan has a large degree of experience in both setting up PubChem and other initiatives as well involved in INCHI and other research work around sharing and accessing research data. We're also pleased to be joined by Professor Chris Evelo. Chris has a long background in bioinformatics, in being a professor at the Maastricht University. And for the purposes of this call, he's joining us with his experience of the WikiPathways work that he's been co-founding and working on with his research team for a number of years. Chris is also involved in a number of other initiatives which are using pathways data to support research, including EU tox risk and previously in Open PHACTS, as well as other Elixir as well. So we're hugely grateful for their time today and for sharing some of their experiences on not just their infrastructures, but probably their experience of using other people's data as well as part of this work. So what we'd just like to do now is that we have some starter questions to get the discussion going, but very much like to get your involvement sort of started too. So as Kira mentioned, by all means begin to put your questions in the questions tab, and I will try and weave them into the discussion that we've got planned this afternoon. So without further ado, I'd like to sort of kick off a bit of an intro on both what Evan and Chris has been doing. So perhaps Evan first, could you perhaps just briefly describe the systems that you manage and a little bit about their variety and volume in this part, and then we'll go into some of the more detailed parts about the updating process later in the session.
Okay, thanks, Nick. So as a part of PubChem, it's a very large data system containing tens of millions of records, hundreds of millions of records cross-linked together. And it's primarily situated around chemical substance descriptions and biological experiments on these chemical substances. It's a resource that's located within the US federal government at the US National Center for Biotechnology Information, which is at the US National Library of Medicine, which is an institute within the US National Institutes of Health. It's an archive, which is to say that records are versioned. We don't really ever delete data. what you do is you have a new version of your content based on what you think it is today. We have hundreds of different data contributors, and primarily you have data being voluntarily pushed into PubChem by our various contributors. About half to 2/3 of the content within PubChem is refreshed on a yearly basis, which is to say that there's lots of content constantly being updated on a daily basis within PubChem that we then have to make public and available as a function of time. We use various Microsoft SQL database systems. We use various homegrown systems, many which are in-memory or memory mapped. We use a number of NoSQL-based approaches, such as Sphinx, Solr, Virtuoso. And we oftentimes have to come up with rather innovative ways to try to make sure that the system scales. One thing that I often tell my staff is that whatever system that we engineer, we need to be able to update within a business week if we had to completely reload the data system, and preferably a business week. And when you have such a large amount of information content, I can tell you that this is a rather monumental task. But we've been up to the challenge, and we have rather robust systems where we've been able to engineer as a function of time, from initially being able to only load 100,000 records a day within our first version of PubChem to tens of millions a day in our current version. Back to you, Nick.
Thanks, Evan, and I'm sure we'll build on some of that, the points you raised, particularly about the no deletion aspect, which I think is a key part for potentially the consumers as well. So, Chris, could you do likewise around your work around WikiPathways?
Yes, sure. Thanks, Nick. So if we look at WikiPathways, it's typically not a big data resource in the sense that it's big in size. It's more big in complexity, right? And that's actually the two dimensions that we typically talk about when we have it about big data. Is it about the amount of data like we have in the genomes, or is it in the diversity of data like we have in all these phenotypic studies, but also in the pathways? We do have WikiPathways as a wiki resource, which gives a real challenge on getting structured updates, because our initial view was like, and it's still there, like anybody can update a pathway any moment and it will go live at that moment. So the actual data at WikiPathways is version per pathway, and we keep all versions. So again, we can always go back, and actually wikis work because it's easier to delete something than to add it. But we also got an increasing request for it being available in different formats and having releases for that, but I will come to that later. We do have pathways there for people that never saw it, which are basically biological processes described in a graphical way and allowing combination with experimental data. And elements in these pathways are the gene products, the metabolites, for which we actually have a connection to PubChem, so the two talks you hear also are really connected, and reactions between these. And we do have that for multiple species, and we do also provide tools that do analysis for that, which means we again have to connect that to basically to that data people want to analyze, which gives us a new challenge in updates, because then you also need mappings, which we get from other resources, and you want to update these mappings in a regular way. And the whole field is developing, which means, apart from what I said about data experts, also new things for data imports. We, for instance, have the whole content of Reactome available. And of course, then all of a sudden, our update schedule starts to be dependent on theirs. I think that will be enough for a start, Nick.
No, great. And I think already both of you are bringing up some really good points about the different perspectives that we need to think of, both as providers of research data, but often, as both of you mentioned, there are links between your systems and other systems in a linked data sense. Keeping it at perhaps an initially a higher level as well, maybe between you could describe some of the use cases that you support. I know perhaps this is a chance for you to drill down into some that you'd already mentioned about both the update and the import, but also think about perhaps what you've seen from your users around their expectations of refresh and the type of, and whether that's changed over the lifetime of your system. Evan, would you like to go first?
Sorry, I had a technical difficulty. Could you repeat the question?
Yeah, no worries. I was saying that we sort of, both of you have covered some of the import and export use cases, and I was just wondering if you wanted to go into a bit more detail, and also whether you feel that that has changed over the lifetime of the system since you started. Have those expectations of users changed considerably?
Oh, I would say amazingly so. In the last 14 years, PubChem went from hundreds of thousands of records to tens of millions to even hundreds of millions of chemical substance descriptions. As we mentioned before about the versioning aspect of PubChem, when you think of it from that perspective, almost half of PubChem is dark data at this point, which is older version content or content that was once available, but then the contributor turned it off. Why would they do that? For example, if you're a chemical supplier, you make particular chemical libraries, and after a while you sell out. And unless you resynthesize those libraries, you're not going to make them anymore. And oftentimes, there's always a huge push towards novelty. So people never really want to go back and make something that's been made before. They want to go and make something new because they think it's more marketable. And so that's really a major push or driving factor. We've gone through many versions, and we went from a situation where we're doing transactional based replication. We then noticed that that didn't really work anymore because it made our front end web services too slow, where you're constantly having to lock tables to update something, and it kept interfering with our user queries. And we had to really switch and to change the paradigms which we use. We also had to come up with new ways to handle and deal with large quantities of data using something like Microsoft SQL Server, which, while it has really grown quite a bit in the last 10 years, it was very much a database system you would use for a small department and not necessarily something that you would use to develop a major system on. But we were able to sort of continue to expand and innovate with our abilities relative to the technology that was available to us. And in some cases, we spent a lot of money to make things go faster based on the technology of the day. And I would say as a function of times, it really got cheaper and cheaper for us to maintain the system. Our user expectations, as the data grew, so did our users. And so that not only did we have to make a system that would respond faster and faster, we also had to handle at times exponential growth in data content that really went from almost nothing to lots, growing at substantial rates year over year, especially in the bioactivity data content, where we have over 250 million bioactivities at this point, or sorry, 235 million. It really was started around a few 100,000 and then kept going up and up and up. Trying to have responsive systems for user queries was probably one of the biggest challenges that we had and faced, and we learned quite a bit along the way. Back to you, Nick.
Great. No, thanks, Evan. You bring up some things that I'm sure we'll cover in a minute. And I say, just a reminder to the audience, by all means, keep your questions. We've had one from Chris Southern, which we'll try and cover in a minute, around perhaps how we connect different sources. But Chris, just building on what Evan was saying about the user expectations and how your perhaps the frequency and the volume has changed over time. Do you want to briefly summarize some of that? Yeah,
especially the user expectations. I think our volume is not increased as impressively as Ivan was indicating, although it's still a steep and exponential growth. the user expectation with regard to the wiki came up immediately when people started to use the pathways we have also for data analysis, and that was basically on day one, because we have stuff on WikiPathways where people are just starting out drawing a pathway that you would not immediately use for analysis, and people are adding to existing pathways new stuff where you're not always sure whether that's the right quality for the analysis. So one of the first things we did is, because we still allowed people to update every pathway at every moment and then basically going to the newer version that could in fact in some cases not be an improvement, we set a flag on these things for the curated collection. That means that you can actually download the curated collection, and there you get at least some kind of a quality mark. And so the update to being in the curated collection and the update of the actual pathway by an edit were two separate things. Although and that's still the case, anyone can actually set that flag. So if you update a pathway and want to use it in the analysis collection yourself right away, you actually can. Of course, that led at some stage to like, yeah, but we want to know about what data we really used, where we have the versions in combination with collections that you download at a certain age, where that collection basically is generated, and we don't keep the collection, but since we have the timestamps on every individual pathway, you can still do that. Then when we went to also making WikiPathways available for other communities, like for the gene set enrichment sets, and especially for open FACTS as RDF, or even the RDF in general, there was, of course, this like, okay, how often do you create the RDF? And it just didn't seem like a very good idea to just create new RDF every new day, because the moment you make it available as RDF, that was an interesting lesson. The moment you do that, people see a lot of problems that we previously didn't see or nobody cared. Like as soon as we uploaded the RDF into open FACTS, we got these comments like, hey, you actually have metabolites in there and they don't have an identifier. Or you have genes that actually have a metabolite identifier. Or you have connections that are not really connected and stuff like that. So having the RDF on one hand allowed us to run a lot more and better and to a large extent automated checks. So we actually do create the RDF every day. We just don't make it available as a downloadable collection as such. And we run unit tests on these so that a weekly curator, and we actually have these, so somebody looking at all the recent edits and all these unit tests that are run on the data, which is not so much that you cannot just fix it in a few hours as a curator, can lead to a lot better quality data. Now, as soon as you do that, you can also say, okay, then there is certain moments where we strike off all the remaining things, somewhat larger curation team, and make an actual release. And that is what happens. So we are now doing about 3 monthly releases of WikiPathways pathways that are so those don't contain the latest edits, but they allow people to work with much more stable versions of the pathways in the sense that they can easier reproduce things and stuff. And we try to have the other export forms like the BioPACs and the RDF to that in parallel. Well, we usually have that.
Great, Chris. And actually, you partly covered a question that had come in already around curation. Maybe I could just ask Evan that sort of question as well around the degree of curation you have to handle with the people that are loading data. Either I know you have different streams into PubChem. Did you just want to briefly sort of talk about some of the challenges you have with curation?
Well, we don't really do any curation whatsoever. We contain curated content. People curate their content and then they push it in. In some cases, especially when it comes to annotation sources, annotated content is in and of itself curated to various degrees. And what we primarily do is we try to ensure that the person who is contributing that content or the organization contributing the content does not make systematic issues or errors. That if we spot things or spot problems, or if our users spot problems, we make sure that we have the ability to communicate, but also to incentivize to have an update inside PubChem. Back to you, Nick.
No, thank you. So I know both of you have mentioned both the volume growth and you touched a little bit about the user expectations, perhaps both in terms of the frequency that people are expecting and maybe the wider frequency of updates in the general literature and just in terms of the volume of data that's generated. Do you want to describe any of the sort of any promising approaches that you think will help with your you know, for the next 2 to 3 years around updating? Is there anything that you're perhaps working on now that you'd like to describe around you know, managing the challenges of updates for this next period? I don't know, did either of you want to go first, or?
I'm happy to start.
Okay.
So in our case, we're playing with lots of different types of technologies. We've noticed, especially in the last few years, the number of options that you have for being able to better search or otherwise distribute your content is becoming more interesting in a way that you could not do before. Primarily, we're talking about cloud, where we're looking at ways where we could containerize our content and then make it readily available on various types of popular cloud type platforms that exist out there. You know, we're talking about the AWSs, the Azure clouds, the Google and so on clouds that one could harness and utilize. But we also have an opportunity here to, you know, rethink the way that we interact with our community. If somebody wants to use that content, maybe they create their own instance and harness that directly, as opposed to us providing those services. We could provide everything that's necessary for them to create their own version of their instances, perhaps even within their own private cloud. So it's, in terms of a promising approach, I would say this is one of those as a way that we could best meet the needs of our users.
Great, thanks. Yeah, and I think we'll cover that, sort of a follow-on to some of that in a minute, but let me see if Chris has got any other things to add from his perspective.
Yeah, it's actually quite different, I think. So I think main things, if it is about getting better and especially more pathway content, is actually not so much technical as it is social engineering. So we're, for instance, running projects with even high schools in the US where they monitor pathways that appear in the literature or even in textbooks and learn them to work with a modern resource like WikiPathways is, and get that pathway in for the whole community, but also for whatever they specifically wanted to do with that. And the same is true for all these unit test-like approaches which we are extending. At some stage, they get us more work. And then the whole idea is, like, can we use social challenges or even Amazon Turk-like approaches or such to get these things fixed, is the things we work on. On the other end, we of course had this idea from the start, like you might want to deploy WikiPathways locally to work with it and to edit it. It turns out that over the years, nobody really wanted WikiPathways like a copy that can actually run as a website and serving as editors, but people want their own analytical environment, meaning they want the collection, they want that combined with the latest version or the version they actually used of the pathway analysis tool they use, which is typically PathVisio in our case, but could be different ones. They want that combined with the mapping tool that gets in between, which is actually one of the things you asked earlier, right? We have these pathways and they allow identification of proteins and genes with different database IDs. And you have your data that again can use different database IDs, and we need to map all that stuff. So there is an integrated mapper based on BridgeDB in that. and that needs mapping data, which also needs to be updated. So now you get a number of different update aspects happening in parallel, like newer versions of the software, newer versions of the actual pathways in the releases, newer releases of the mapping tables that are being used, which immediately leads in the direction of, can we containerize all that stuff so people have a version available that has all of that in it, which is developments we're working on. We have containerized versions of BridgeDB, for instance, but not yet of the whole set. But I think that's really important stuff to go for.
Great, no, thank you for that. And just to perhaps bring together a couple of points, I think both of you mentioned, Evan mentioned perhaps the challenge or the change in process, where I suppose this has always been the case, where certain organizations want to bring data in-house because they both have a need for access to the public data as well as generating their own data, and how do they then map that together? And you bring that up as well, Chris. Back to Evan, do you know the sort of volumes of the sort of downloads, for instance, for your entire instance? Do you get a sense for what the percentage is between those using locally versus querying, actively against your APIs?
Well, this is a very difficult question to answer, in part because while you may have one unique IP address, and essentially one user download the entire content, they could be serving that content to a host of thousands or 10,000s, or it could just be a single person wanting to utilize this for some research project. What we do notice is that we provide certain types of data available on the FTP site, and that there are others that try to systematically download certain types of other content that may not be available for bulk download. We see through the number and types of users that keeping effective mirrors of our content has proven rather troublesome, in part through the rise in the number of pharma who are using PubChem interactively as opposed to perhaps locally in-house. So there's also anecdotal information that it's become too much to maintain and too costly to maintain for certain types of research organizations to have their own copy, because the data changes too often, and having something that is updated on a quarterly or yearly basis may not be sufficient for their use case. So I would say that it provides a great degree of difficulty when you have and try to mirror large data sets, even today. And some of these other approaches that I mentioned in terms of cloud or otherwise may afford the best opportunity for folks, because chances are they already have a cloud provider. And if we were to containerize our content in such a way that they can utilize it within their cloud provider, they can spin up their own private instances that would then work for their needs, where we would be effectively maintaining those data streams for them.
Yeah, no, that's a great point, and I suppose we've seen some of that with other research data as well. With access to genomic data on Amazon and Google Cloud. I mean, and as you say, that may be what's going to happen over the next 12 to 18 months, and certainly from our experience of open facts, it is that different types of data. There is very much different expectations of the refresh frequency from some data sources maybe aren't refreshing more than once a year or a couple of times a year, to more time sensitive data like patents, where there is new data coming in every day as the patent literature is mined and added to the patent sources. So certainly that choosing the right frequency is a key aspect. Chris, in terms of perhaps you have some different dimensionality to your data, was there anything else about the as you say, people wanting your ability to deliver RDF seems to have been a real success, because people can then use that to link to other sources that they have. Was there anything else about the update process you wanted to mention?
Yeah, there are a few things. The first thing is, of course, people indeed reuse what we have, and they do that in different ways. And there are all kinds of initiatives for meta tools that then have all the pathways from all the sources somehow available for statistical or graphical or whatever. We see a typical problem with that because oftentimes these meta resources have older versions than we have. And we actually get complaints from users, like we work with stuff from you and it's outdated, but they don't get it from us. Of course, then we can just blame the ones that don't update, but we can also try to make it easier for them to regularly update or collaborate with them, like can we actually push information to you or something like that, which I think are really important developments. And it depends in part on social engineering. Like it's really helpful if people actually start to talk to each other before they do updates, right? So you can get them in a useful way. Then we see that the typical user can be quite different. Like you have the typical biologist that actually wants to use pathways to do analysis with, and they typically download the pathway analysis tool, and then from inside the tool download versions of the pathway database and the mapping database. On the other hand, there's also other tool providers that sometimes are not even known as such, and that either do the same, like Agilent does the same. In Agilent GeneSpring, they have WikiPathways integrated, and they download versions of the pathways again at some irregular basis, in fact. And Affymetrix does the same for their pathway analysis on what they offer in their analysis suites online. And there they use our API, which is something we only found out when we changed the API, and we got an immediate email from Affymetrix like, hey, your service is broken. So it's like Evan said, it's sometimes hard to realize who's really using what and how often. For instance, if you download the pathway tool and do the update of the database, that database is actually provided by the web service. So then it's an interactive user using the web service, essentially. I'm not sure whether that's a problem, though. I think the synchronizing of the data that is out there in the world, making it available to other resources in such a way that they can do regular updates might actually be more important.
No, thanks. You've done a good job of almost preempting a question that Christine was asking about API, and you mentioned the API that you provide. And maybe this is both a question and also perhaps some of your thoughts about the principles of API, given that the power of the web is a lot driven by all the core systems providing a good API service. I'll go to Evan in a minute, but just to sort of build on what Chris said, but perhaps a question for Chris in a minute is, would there be anything else in terms of your testing of your API? Do you use your API yourself for some of the services that you provide on top of WikiPathways?
Yes, we do. And the typical thing is that then you see volume differences, right? We have, for instance, an API for our mapping servers that is called by WikiPathways. Every time you use it, as soon as you look at a gene and want to see all the other database IDs from that gene has next to the one that actually is in the pathway. And we never break that one because that is interactive use of the wiki being served up by an API. On the other hand, and the same is true for the WikiPathways API, where you can search for specific pathways or download the whole set or things like that. That is still a relatively low volume work. On the other hand, we have the BridgeDB mapping service as such, where people can say, oh, please give me the gene ID for this list of 200,000 proteins in whichever gene database. And then they typically ask that, don't send that with one batch query, but ask 200,000 different queries or such, and actually manage to break our API or make it really slow. For which we then provide local installable versions of these tools. often as part of packages. Like if you run BridgeDB in the R environment to do again statistical analysis on it, the BridgeDB package installs a local local BridgeDB web service, and the same is true where we have that stuff integrated in Cytoscape, which basically uses the same mappings, does that for network tools, but yes, you use the API approach, but do it in a local version. So we have a lot less problems about robustness of the services. That said, we're actually working on a more robust service for especially mappings, making that available. Since the community suffers a bit from the tool that is most often used for that is still David. David recently was updated, but that was the first update in 8 years. So we thought we might want to have a little bit more community-oriented way of updating that kind of stuff.
Okay, no, great, thank you. And just perhaps just a reminder to everyone online, by all means, carry on with asking questions. We'll probably be able to have time to pick out one or two more. But I just want to turn the question about APIs back to Evan. I know you mentioned a little bit about the downloads, but do you want to perhaps go through some of the principles that have helped you define your API, as well as whether you see any challenges in the future with either maintaining it or expanding it?
Sure. Well, I can tell you that analysis APIs are kind of going the way of the dodo bird, in part because nobody is really willing, at least in terms of our user base, to use our analysis tools to the extent that they used to. They appear to want to ask natural language questions and get back an answer. And if they don't get an answer, they don't actually use or try to learn to use analysis tools oftentimes to find that information, unless they absolutely have to. More what we've been trying to do is to make our information content more amenable to natural language questions. So that way, when you go to Google or Siri or whatever, you can ask a question and get back an appropriate answer. So making our information content more machine readable, as well as to focus more on data views that help to basically create a analysis on the fly, but that isn't really an analysis that's user driven, other than to go to a particular record and to find out what this entity is about, everything that's similar to it, perhaps to not to consider a singular entity, but to consider a group of entities, and mapping things to terminologies that are hierarchical in some type of fashion. So if you're interested in a particular steroid, maybe you want to generalize and say, steroids in general. Not a particular form of cancer, but say a particular type of bladder cancer, maybe all cancers you might want to consider. So trying to work more towards that. A lot of our APIs, we try to make return as soon as you as soon as you ask the question. The idea is to return an answer in less than 100 milliseconds. And if we can't do that, we have to really think carefully about whether or not we want to expose that type of analysis tool. We have linked data, for example, but we don't provide an open linked data endpoint, in part because you can ask a question that can return in microseconds or in micromillennia. It's just too much information content. It's hard for people to grasp and otherwise to digest. But we serve millions of web hits a day just for programmatic services. We also serve millions of web bot hits a day. These are folks who are at Google or Bing, Baidu, and others who are trying to crawl our content so that they can answer those types of natural language questions.
No, great. Thank you for that insight. So again, as we sort of bring the webinar to a close, we've covered a lot today, and it's almost probably we could think about organizing a session. I'll let Chris and Evan sort of summarize any other thoughts they have about the challenges they have for not just perhaps their resources that they've so eloquently described, but also perhaps the challenge going ahead for all of us as consumers of not just their content, but the wider content of literature that we have out there. So to back to Chris and Evan, did you want to sort of any closing remarks about what you see as the challenges ahead beyond what you perhaps described today? Could I ask Chris first?
Well, I think Evan actually brought up one when he said that people are starting to not use analysis tools, or kind of expect that you can just ask the regular question and get an analysis tool to do all the stuff you wanted to do in the back. That is not typically what I see in the pathway users, though. I see it in some other bioinformatics community. Pathways are either explored, like I really want to understand that thing without doing any data analysis at all, and that they do in an analytical or in an interactive way. On the other hand, I see a huge uptake of all the connections we have to network and graph environments, where in fact so far the network biology approach, so having a import tool for pathways in Cytoscape and having apps in Cytoscape that extend that or allow analysis on the complex data that such a pathway provide, actually is used quite a lot and is leading to a next stage in analysis that goes beyond the traditional pathway approach. And that is actual people using real complicated approaches. And we recently ran a course here about automating Cytoscape approaches, for instance, which was really well attended and seems to serve a purpose. I had more in mind, but let's go to Eva.
Thanks, Chris. Yeah, Evan, anything to add to that or build on what you said before?
I would say that most people who are getting into the area now are very, very lucky that they didn't have to do it 10 years ago. Really, the landscape has completely changed. Instead of worrying about finding any type of open data that you can then do some real science with, you're now at the point where you almost have too much information. You sort of have the rise now where it's not humans that are digesting information content, it's computer algorithms through so-called neural networks or artificial intelligence. I think the more that resources such as Chris and mine and others are trying to make the information content more readily available, not just to humans, but to programmatic interfaces that are run by computers, perhaps, or as we try to annotate the information to a degree that a computer can start to understand it in some way, it really makes for a easier time for you to integrate the vast degree of content behind the scenes and to perhaps start thinking more about the content and the knowledge and changing the science and making discoveries, as opposed to finding the information, analyzing the information content, and putting it all together. So I'd say the next 5 or 10 years, they're going to see really a major sea change in how we do science, in part due to the availability of this content and the fact that it's updated on a regular basis with new and dynamic content.
Can I follow up on that? Because that is actually where I see a lot happening, but I also see some caution signs that should be made. People are more and more able to quickly connect data that is available in different places. And I've seen exercises where people, for instance, looked at all the known asthma genes or all the genes being differently expressed in asthma from resources like DisGenet and ArrayExpress, and then finding all the pathways where these genes are present. And I saw very enthusiastic responses of some data scientists doing that. And when I looked at the results, I thought, oh, geez, if that's all we know about asthma, there's something really wrong. Meaning there's still a lot of stuff in finding the data and in connecting the data that we should get right, and that doesn't show so clearly if you're doing this kind of complex analysis. Like is asthma actually mapped to an ontology term that describes these pathways that are connected to that, for instance, right? Which means organizing the pathways using a pathway ontology approach. Are the ideas used in Array Expressed and in WikiPathways actually mapped to each other in all cases? All these things turn out not to be the case when we really looked at it into more detail. And that's fine, but it means that people still need to be aware of what do you expect. It's a bit like the headmaster of my primary school still telling you you need to do math calculations in your head, even if you have a ruler for that, and now we have computers for that, because the only way to see that it's reasonable result is just to use common sense. And that's true for biological results too, right? And then the other thing there is that if I meet people wherever in the world, they oftentimes now know WikiPathways, and then they always have this, yeah, Chris, you know, I tried this and then it didn't work. And then it's why do you only tell me that if you meet me? Right? Why don't we get the feedback at an early stage so we can actually improve stuff? And I think that's true for a lot of things that people try and then go away to something different or build their own. And where getting into contact, working in it together, or just filing a bug report would help loads. And of course, with computers and software in between, that gets less intuitive, but we still should.
No, thank you. And both of you made some really... Sorry, Evan.
No, that was Chris. Somehow I made this in almost social science talk, which was not my intention, but I think that's a really important aspect.
Yeah, no, I was going to sort of, in a way, perhaps try and just wrap up a little bit, and firstly, thank both of you for some really engaging comments, not just on our sort of questions that we thought of before, but really teasing out both some of the things that you're doing at the moment, as well as looking ahead a little bit. I thought both of your last two comments were very relevant about how do we better engage with the user community, but both at a sort of a more fundamental level of checking on requirements, but also making sure that we can collect issues as soon as we can. And then Evan's point about the growth of perhaps machine-to-machine based analysis and how to make data more accessible to AI and ML tools in the future, where huge collections of data will be passed through these algorithms and toolkits, but they still need a degree of augmented human analysis to make sure that the data results are still relevant. And it sounds like we could even have another webinar on some of those themes. But I'd also like to thank the audience for their questions today and engagement. We will be posting a recording of this up on the website, and we certainly would welcome ideas about how best to perhaps do a follow-on to this, either under the umbrella of Open Facts or bringing together others in the future around this challenge, which certainly remains going forward. But it leaves me to thank both Chris and Evan, and wish you a good rest of the week. Thank you very much for your participation.
Thank you very much, and happy holidays.
Cheers. Thanks, Chris.
Thank you,
and
Kira, for the work on organizing this.
Yeah, thank you again for coming. And yeah, as Nick said, we'll put the recording up on YouTube, and we'll be able to see it via the Open Facts website or by Big Data Europe. So thank you.
Thank you.